Okay. Even if you don't understand problem 2, it doesn't matter. I just want you to raise your hand if you can tell me the general difference between problem 1 and problem 2. Read it. Go. I don't need lots of specifics. I just need you to recognize that there is a difference between problem 1 and problem 2. Raise your hand when you can kind of tell me the general difference. Feel free to talk if you want to. So hey, listen, hands up. Understanding exactly what they're saying is not necessarily the easiest thing in the world, so we'll talk about that together. But raise your hand if you can sense the difference. It's not really too bad. Never mind. I'm really failing today. Here's the difference. In the first problem, the volume is created by rotation. So look at the words and make sure you see that they talk about the volume is created by rotating or revolving. Memorize. Add some music to the video. I feel like they need a new song. It feels like Christmas. But anyway, sing like the Beatles or something. I want to hold your hand. I don't know what. Something a bit more upbeat. I once heard the Utah Symphony play I Want to Hold Your Hand by the Beatles. It sounded amazing. It was like, whoa, that sounds cool. Like a whole symphony orchestra, like this professional. It was like, whoa, that just blew me away. I'll stop mumbling now. Look! Okay, please memorize. We have 2 in there. That's because I was grumpy. Look. If the volume is created by rotation or revolution, the slices are always circular. So they'll either be a solid circle like this or a circle with a hole in the middle. Always. It's created by revolution. The slices look like one of these. Problem 2 is different. It specifically says the slices are square. Can you see that it says the slices are square? Okay? So there's no revolution. There's no revolving. The slices simply sit on the region. So here's the region again. Here's the region. I have some videos that help this, but I can't show them because it's crashing. So here's the region again. And the solid is created by taking a slice that's square and stacking it on the region. So this slice cannot go here. It's too big. It has to go right there because it has to fit on the region. Then this slice, this video is a little hard to see because they can't see what I'm doing. This slice goes here. So if you stack up the slices, you get something like what I tried to create here. Like that. Look at it. Okay, again, it really doesn't matter that you can visualize the solid. All you care is that when you read the prop, like this, look at me, it's more important that you don't try to visualize the solid. You just want to visualize the slice, because the trickiest problems they'll give you, they'll try to fool you with the shape of the solid. Pay attention to the shape of the slice.
So is it like sort of more calculating now from like almost like a pyramid kind of shape?
Kind of, but again, we don't care that it's a pyramid kind of shape. All we care is the slice.
Yeah, but it's not going to be like...
No circle at all. Like there's no curve at all. Well, there's kind of a curve in that as these go this way, they're getting smaller so that the volume has a curve to it, but every slice has no curve.
Yeah.
Square only.
So they're always going to tell you what the slice is?
They'll always tell you what the slice is. Here's how they tell you. If the solid is created by revolving, you know, circle. Otherwise, they'll say The slice is a square. The slice is a rectangle. They don't use the word slice. They say cross-section. Means the same thing. So if the slices are rectangles, they look like this. Okay? They'll say the slices are semicircles, hence all the toys that are on the desk here. Okay? Question? Please.
The slice isn't the square. Did they tell you like how all it is, or like if it's a rectangle?
Yes. What they'll say, Bryn, square doesn't matter. Bryn noticed that because the square is the same height as, the dimensions are all the same. If the slices are semicircles, they have to sit on the region. So they can't sit like this because that's not flat. They have to sit like this, so you do know the orientation.
Okay.
If the slices are rectangular, they'll tell you how high the slices come up off the region. Is that your question?
Yeah.
2 points. Okay. Finding the volume is easier than with rotation because there's never a hole in the middle of it. Because, nicely done. Because the solid looks like this. There's no hole.
Rectangle or
Okay?
square?
It's like this actually because they sit on the region. Got the idea? Like it sits like that.
Yeah.
See it? See it? Okay. No hole. All we have to do be in modern dance. Okay. That would be a good prop. My sister-in-law teaches modern dance. Look, so I've been to many modern dance concerts. The square, all we gotta worry about is the square. Just say it out loud. How do you find the area of a square? Never mind. Stop with the choral responses. Raise your hand. How do you find the area of a square? Come on, raise your hand. Get your hand up. Hands in the air. How do you find the area of a square? Julia. You just take this dimension times this dimension, right? Okay. When I put the square on the region, watch. It sits like this. That's one edge of the square on the region. And then it comes out of the board. So to find the area of that square, I simply need to know how long this is. Easy. Y coordinate at the top minus y at the bottom. So if I take F, subtract G, that's the length of that pink line. I need to multiply that by itself. That's what squaring means. Question? So this is the formula for the area of one square slice. The X indicates which slice. Do it for every slice, multiply by the thickness. Done. Type it in your calculator. Please.
Wait, why is it squared again?
So I'll have you say it, then you'll remember better. So every slice has what shape?
Squared.
Good. So here's the shape of a slice. I pick up that slice, turn it. So here's this slice, right? I pick it up, I turn it on edge, and I set it on the region to start creating the solid. So to find the volume of the solid, I don't worry about the shape, I just find the volume of a slice. So I have to take this dimension times this one. What does it mean to square something?
Times it by itself.
Right, that's how I find this area. This times itself. 2 points.
So you only do square if it's square and not really.
Yeah, really what you're doing is this. You're just saying, I need to take F subtract G, because that's the dimension for one side of the square, and do it again. But it's just easier to write square. But same thing. So this would also find the volume of the solid. 2 points. And look at this rectangle. Look. This rectangle area, here's what I think is interesting. Watch this, check. Perfect, look. Roughly. Notice how the rectangle is just twice the square. Can you see it? So if this rectangle were 5 times as high, the area of the rectangle would be 5 times the area of the square. So if they say this is the shape of the slice, then I'm going to have something like this. 0 to A, 2 times the area of the square. That would find the volume of a solid if the slices were this shape. We draw it on the board so this would be slices that are rectangles like so. This is square slices. This is square slices. Justin, please.
So why do we have to do the rectangle 1 by 2?
So are you comfortable that to find the volume of the solid, we do it one slice at a time? Are you comfortable that the volume of this slice is the area times dx? Good. This area is literally twice this area.
Oh, okay.
You see it?
Yeah.
So I found the area of the square here, or the area of the square here. So the area of the rectangle is just twice, 2 points, or 3 times, or 4 or 5, whatever. Mary.
So are we only ever going to do it that way, or are we going to do it where we do like the length times the width, the rectangle?
If you did it that way, you'd get this. So if we had a rectangle that was twice, 2 to 1 ratio, you could do this if you want. You could say I go F subtract G multiplied by 2 times F subtract G. Is that what you meant?
Yeah.
But these two are multiplying together, so they're just squared. So it's the same thing. 2 points, Justin?
And then how do we know if it's like 2, it's like twice the size of the square, or like 5 times? Do they tell us?
They'll tell you.
Okay.
So, questions here before I stop the video to make sure we get a recording? Cool.